due to this second segment of wire. So we'll redraw segment 2. The current comes around this way, goes from here to here. Point P is at the center. Our current comes around in this direction. So there's our current I. Let's write down our savart law. Magnetic field is equal to the integral of mu naught over 4 pi times I times ds cross r hat over r squared. Let's deal with ds cross r hat first. So the magnitude of ds cross r hat is the magnitude of ds times the magnitude of r hat times the magnitude of the angle between them. Let's get these things straight. ds is a little bit of path along our wire in the same orientation as the current. So ds looks like this. R is the vector that goes from our path element to our point P. There's R. And r hat is a vector that points towards P, a unit vector in the direction of R. So if we ask what's the angle between ds and r hat, ds is tangent to the circle, r is a radius, it's perpendicular to the circle. An angle between the tangent and the radius is 90. And the sine of 90 degrees is 1. So this leaves us with the magnitude of ds. So then to find the magnitude of our magnetic field, so that's B1, this is B2. The magnitude of our magnetic field is mu naught over 4 pi times I times ds. I've substituted in the magnitude of ds cross r hat over r squared. Let's take our constants out front. Mu naught I 4 pi r squared. All those things are constant. We're left with the integral of ds. The integral of ds, let's see if we can figure this out. Right off the bat, we probably know what it is. It's halfway around the circle, so it's going to be half a circumference. We can also write it down in terms of integrating over the angle that we have in this problem. From a high school math class, you may remember that an arc length s is radius times angle. That means a little bit of arc length would be a little bit of the radius, would be the radius times a little bit of the angle. So the integral of ds is the same as the integral of r times d theta, because that little bit of ds subtends an angle, a little angle that we would call ds. If we're going to integrate with respect to theta, we have to ask what angle do we integrate with respect to? Well, it goes from here over to here, so the range of angle is 0 to pi. It goes over a half a circle. So we've got r outside the integral of d theta from 0 to pi. The integral of d theta is just theta. That's evaluated at pi and 0. So our answer would be r times pi. We can fill that in up here. And we can simplify. Pi cancels. One of those r's is gone. We've got mu naught I over 4 times r. And magnetic field, of course, is a vector, so we need to get the direction of the magnetic field. So B2 is going to be mu naught I over 4r. For the direction, there's two ways we can do it. We can do our right-hand rule, which says that we point our thumb in the direction of current. So I'm just going to turn my paper, otherwise my hand's going to get all bendy. My thumb goes with the current in this direction, and then my curled fingers show the direction of the magnetic field. My curled fingers are pointing into the page at point P, so the direction is into the page. The other way you can do it is the right-hand rule that says the direction of B2 is the direction of ds cross r hat. That would be your standard right-hand rule, where ds is your thumb, r hat is your index finger, and B is your middle finger. So let's try it that way and see do we get the same answer. So ds is our thumb, r is the radius of the circle. Again, I'm turning the page just to make my life a little easier. Then what does my middle finger do? Goes right into the page. So both right-hand rules give the same direction, and that's because really they're the same right-hand rule. Okay, so the direction of the magnetic field at point P is into the page. There are two ways you can write down your answer. You can use Cartesian coordinates. I'll do it that way. X, Y, Z. Positive Z is out of the page. This one is into the page, so the direction is minus k hat. Okay, there's our magnetic field due to segment 2. Next we'll do 3 and 4.